Hello, Djordje Romanic here. Welcome to Fundamentals of Weather and Climate. In today's video, we are going to discuss specific humidity and mixing ratio. Now, what is specific humidity? Specific humidity is usually denoted with small q, and it is mass of water vapor divided by the total mass of air in a given volume. And as you can see, this is non-dimensional quantity. It would be kilogram and kilogram, but we often give it in the units of grams per kilogram. Why do we do that? Because it's convenient. We can say how many grams of water vapor is in 1 kilogram of moist air. And that is called specific humidity. Other quantity is mixing ratio, denoted with little r, and that is mass of water vapor divided by the mass of dry air in a volume. Again, it's a non-dimensional unit, it's a non-dimensional quantity, but we often express it in grams per kilogram. This is called mixing ratio because it tells us how well water vapor is mixed with other gases that might make up air. Because this total mass of air can be given as mass of dry air plus mass of water vapor. Now, mass of dry air, what is dry air? That's nitrogen, hydrogen, argon, CO2, and so on. All other gases that are not water vapor. So mixing ratio then tells us how well water vapor is mixed with other gases that make up air. Now, because most of the mass of a parcel of air comes from dry air, it follows that MD is usually much larger than MV, and therefore these two quantities are often very similar. In other words, the difference between specific humidity and mixing ratio is usually less than 1%. So in terms of the values, they are similar, but in terms of the meaning, they have different meanings. And they are so similar that sometimes some meteorologists use them interchangeably. They shouldn't do it, but sometimes they do it. Typical values for these two quantities in the atmosphere around us are between 2 and 18 grams per kilogram. So 2 to 18 grams of water vapor per kilogram of dry air or moist air. Again, difference is usually less than 1%. Now, these two quantities are much better to quantify moisture of air than the absolute humidity that I discussed in the previous video. The reason is you can see that these quantities will change only if MV changes, if the mass of water vapor changes. Because remember that absolute humidity A was also mass of water vapor, but it was divided by volume. So if we change volume of air, absolute humidity changes. But here, if we do change volume of air, changing volume of air doesn't change mass of moist air or dry air. So changing volume of air doesn't affect these two quantities. So they are preserved if the volume is changing, which is not the case for absolute humidity. So in other words, specific humidity and mixing ratio will only change if the amount of moisture in the volume of air changes. And that's fine. That's what we want. We want quantity that changes when the amount of moisture, water vapor, changes in a volume of air. And that's why these two quantities are used much more than absolute humidity. In the next video, we are going to discuss water vapor pressure and saturation water vapor pressure. Until next time, goodbye, and make sure to like, subscribe, and share this video.